So in this session, you will be able to understand about what is meant by a producer, a consumer, and then Zookeeper. So also in producer, what is a producer? And then producer with message key. In consumer, consumer groups, and then consumer delivery semantics. And then in the Zookeeper, what is a Zookeeper and its role in Kafka? So these are things we are going to typically understand about. So let's talk about producer. So I believe with the help of yesterday's session, you already got some familiarity what is meant by producer. Simply, producer publishes the data to Kafka. So it could be any application, as simple as that. So producers write data to topics, and producer automatically know to which broker and partitions they write to. For example, I have a Kafka cluster, and one second. So I have a Kafka cluster. So it could be a single node Kafka cluster, or it could be a multi-node Kafka cluster. So I have a Kafka cluster, and let's assume it is having, if it is a multi-node Kafka cluster, there would be, let's assume there are 5 brokers, say broker 1, broker 2, broker 3, broker 4, and broker 5. And let's assume I have created a topic inside this Kafka cluster. So let's assume I have created this topic with 3 partitions. So as there are 5 available brokers in this cluster, creating a topic with 3 replication factor, that is absolutely possible. So one copy of this topic will be here and here and here. So remaining 2 brokers will not be having any entry related to that particular topic, because out of 5 brokers, although you have 5 brokers, you created the topic with a 3 replication factor. So 3 copies are now created. Now, whenever an application, whenever a producer from the client, he tries to publish to the message to that particular topic, the thing is, in his connection parameters, he has to give any minimum, any one of the broker. He no need to give all the brokers list. So this is one server, this is another server, this is another server, and another server. So he will give one broker name. So that's it. So if he is connecting to one broker, it means at the back end, he will be connecting to all the 5 brokers in the cluster, right? That's what we have seen yesterday. Okay. So for example, in my Kafka cluster, I have 3 brokers, say broker 1, and running at a port number called 9092. 9092 is a Kafka default port number. Okay. And they have another broker called broker 2 9092. They have another broker 3 9092. Broker in the sense it's a server only, but in Kafka world we call the server as a broker. So another broker 4 9092 and another broker 9092, which is broker number 5. So total there are how many brokers? Total there are 5 brokers. Now the application people, we have given to the application people, hey, these are all the 5 brokers running at 9090 in my Kafka cluster. Now what application people will do is, so they will write down a producer program, say Kafka console producer, some producer program they will run, and there is something called a bootstrap server. Bootstrap server means our broker list only. So the thing is, they can give all the 5 brokers list like this. So there would be no spaces when they are giving the things. And then they will give something called -- topic and then the topic name, say TP1. So they can give like this, all the 5 brokers they can include, or they can give any 2 brokers. Let me do one thing. So they can give any 2 brokers like this. So this is also the right option. Or if so, if they have given something like, let's assume only 2 brokers they have given, this is also same result. Or they have given only 1 broker, this is also same. Everything will give the same result. They have to connect any minimum one of the broker of the entire Kafka cluster. So ultimately everything will give you the same result. So this is how they will include the brokers list. The thing is, once they connect to 1 broker, right, that's fine. So they will be connecting to all the remaining 4 brokers at the back end, and data will be published. But the thing is, in the case of broker failure, producer will automatically record. For example, let's assume they have given all the brokers. And what happens is, initially, a producer will verify if the connection is fine in this broker. If the connection is fine, then the producer will not take care of all the remaining 4 brokers. It will directly connect to here and it will set for this topic and will produce the messages. And let's assume, let's say in this cluster, this broker is down due to any issue. Now the producer will automatically know, okay, now I need to connect to this broker. Now it will publish the messages by connecting to this broker. Now let's assume these 2 brokers are down. That's fine. Remaining, I have another connection name. So I will try to connect here. If this is fine, I will successfully publish the messages. If this is also down, then I will connect to broker 4. If this is also down, then I will connect to broker 5. If all 5 brokers are down, then this producer will be unhappy. This producer won't produce any messages. So that's how it is. If any broker goes down out of the brokers list you have given, so a producer automatically know, okay, I have to connect this, or I have to connect this, I have to connect to this. It will, this load balancing will be automatically handled by Kafka itself. You don't need to worry about it. Only one thing is, you have to give the available brokers list. That's it. But in the case of you are giving only one broker list, and this must be available. If this one broker is down out of 5, that's all. This producer will be unhappy and it won't produce any message to target, because you have given me only one broker list and I'm connecting to this, but this broker is not available. So I can't produce the messages. So that's how it is. Okay, see? So the load is balanced to many brokers. So thanks to number of partitions. So as we have number of partitions, Kafka will decide, okay, this partition is free, message should go to here. Or this partition is now free, so message should go to here. So that will be internally decided by Kafka. Okay. So producer can choose to receive the acknowledgement of data rights. For example, if any producer produces the messages, so what does a producer, how does a producer gets confirmation? Yes, my data has been successfully published. The thing is, producer can choose to receive the acknowledgement of data rights from Kafka brokers. For example, see, a producer is producing the messages like this, and come on. So there is something called AX equal to 0. It means whenever a producer producing the messages, like whenever a producer producing the message like this, at the end they can choose something AX equal to 0. There is it is a producer property. So it's like okay. Anyway, so this producer property we will discuss in the Kamal interface. Okay. So they can choose X equal to 0. I mean, the producer can choose X equal to 0, or X equal to 1, or X equal to R. These 3 acknowledgement that producer can choose while producing the data. Let's assume producer chooses X equal to 0. It means that producer won't wait for the acknowledgement. For example, producer is producing the messages and it has chosen, hey, X equal to 0. It means, hey, Kafka, don't give me any acknowledgement. I totally trust you. So you just blindly proceed. So that's what the meaning of X equal to 0. But the problem is, there is a possible data loss. For example, a producer is producing the message to broker 101 with X equal to 0, right? And the message is in the air, and the message is, when it is in the air, let's assume due to some network issue, message got vanished. So the producer never wait for broker acknowledgement, and it will blindly proceed for the next message. The reason is, X equal to 0, it means you are not waiting for acknowledgement. And although the message is vanished, you are not taking care of that. So if data is lost, that's it. Your data will be lost. The producer does not know if my data has been successfully published or it is not done. So there would be no guarantee of that. This is what X equal to 0. And let's assume X equal to 1. It means that producer will wait for leader acknowledgement. For example, okay, I will show you something here. Topic A, let's assume topic A is having only one partition. So topic A, and it is having only one partition, but it's having 3 replication factors. As we have 3 available brokers in this Kafka cluster, 3 replication factors is available. So one partition means, so this will become also partition 0. This will become also partition 0. So topic A, 1 partition, 3 replication factor. So partition 0, 1 replication factor is broker 101, another copy is in broker 102, another copy of partition 0 is in 103. Let's assume for partition 0, broker 101 has been elected as a leader, and broker 102 for partition 0 is a follower, which means in sync replica, and broker 103 for partition 0 is another follower, another in sync replica. Let's assume this is the case. It means that whenever producer chooses AX equal to 1, it means producer will wait for leader acknowledgement. It means whenever message is published, so what producer will do is, producer will never go to next message to process. What it will do is, hey leader broker, please give me acknowledgement that data has been successfully written into your offsets. Now broker will give you, at the back end, broker will give you some acknowledgement. Yes, I have successfully received your acknowledgement. So then immediately producer will go for the next message. It will try to produce the next message as soon as it has received the acknowledgement from the broker. And producer will never wait for the follower brokers, because if X equal to 1 means it will wait for the leader acknowledgement only. So it will never wait. Is my data got replicated to all the followers? That thing will not be verified by the producer, because X equal to 1 means only it will wait for the leader broker acknowledgement. That's it. But here there could be limited data loss. For example, your message will be definitely there in leader broker of partition 0, that's for sure. But after message being published, as this partition 0 is having another 2 copies in another brokers. So these in-sync replicas, they have to replicate the data to this broker, and they have to replicate the data to this broker also. But this producer will never wait. Is my data get replicated to all the brokers or not? No, it will not verify for that. So whenever data is getting replicated, if there is a loss here, then it's loss. So it's a limited data loss. In broker, your data is there, but it is getting replicated to all the in-sync replicas. There is no guarantee of that, because you are not waiting for the followers acknowledgement. That is what X equal to 1. And this X equal to 1 is the default behavior of Kafka while producing the messages. So clear with X equal to 1, a producer will use all the brokers list, and from which broker it has to read, it will automatically know, right? In the same way, whenever a consumer consuming the data, they will use some command called like this: Kafka console consumer, and the bootstrap server is going to be all the Kafka brokers list and then the topic name. Now consumer know, okay, should I connect to broker 1, should I connect to broker 2, or should I connect to here, should I connect to this, should I connect to broker 5? So the consumer automatically knows which is available broker, and from there it will consume the data. So whatever the concept that is applying on producer side, the same concept will be applied on the consumer side as well. So in the case of broker failures, consumer know how to recover. For example, we have given all this list, right? Out of this list, let's assume when the consumer is consuming, let's assume this broker 1 is down. So now what consumer will do is, okay, this broker is down. Fine, let's try to connect to this broker. If this is available, it will try to connect to this topic and it will try to consume the data. And let's assume if this broker 2 is also down, now consumer automatically goes for broker 3. Is this broker available? Yes, this broker is running. Okay, now let's connect to TP1 and then consume the data. If this broker is also down, that's fine. I have another two in the list, right? Let's connect to broker 4 and get the data. If broker 4 is also down, then fine. Let's connect to broker 5 and try to consume the data. If all the brokers inside our Kafka request is down, then the consumer will be definitely unhappy and will throw you an error called, hey, broker is not available, I can't consume the data. So you will get such kind of error. Okay. In this notepad, see, a consumer is consuming the data by giving all the consumer groups, and also in the real time, whenever a consumer is consuming, they will use some group called, say, G1, where G1 is the name of the group. So here G1 is a consumer group in this Kafka. With the help of this group, a consumer is consuming from a server. Also, there is another consumer. Let's assume this is application server 1, where producer program is running. Now there is another application server, say application server 2. From the same application server, another consumer is running with the help of same group G1. It means now in G1 group there are 2 consumers. So this is in one IP address. Say okay. So this is host name application server 1, and this is another host name application server 2. So 2 consumers are using same consumer group. It means now in G1 consumer, there are 2 consumers. Let's assume there is another application server. So application server 3, where consumer application is running, and it is also executing the same command in its program, and it is also using same consumer group. It means now in one consumer group, there are how many consumers? 3 consumers are running. One consumer from application server 1, another consumer from application server 2, another consumer from application server 3. Okay. So like this, they can use a group ID. So group ID means here G1 is a group ID. It is called as a group ID or group name. Both are first the same thing. So the thing is, what is the advantage when they use the group ID? What is the advantage? Why they have to use this group option? Why can't they connect as an orphan connection without using any group ID? Why can't they connect? What is the extra advantage you are going to connect as a group ID? Simply, you can say whenever a consumer is using a consumer group ID, that particular consumer will be having an identity. If in Kafka, that particular consumer is having an identity, it means Kafka knows, okay, this consumer group has committed how many messages from that particular topic, how many messages it has consumed. Some kind of identity will be there. For example, see, when we born, right, what's our identity? Our parents only. Wherever we go, we inform, hey, these people are my parents, right? So that we will be having an identity. But if you see, there are orphans, they don't have any identity. So they, when they do something, they will be faced, they have to face so many complications, right? Because they don't have any identity, because they are orphans, right? Same way, whenever a consumer is consuming, in real time, they will give a group identity for that consumer. So that Kafka will identify, okay, this group ID has did this work in my Kafka cluster. So Kafka will get such kind of identity internally. That's the purpose of giving a group ID. Whenever, let's assume from all these 3 application servers, all these 3 consumers are connecting at the same time by using same group identity. And they are connecting to the same Kafka cluster, they are connecting to this topic 1. And let's assume this topic 1 is having only one partition. Now this one partition will be assigned to either this consumer or this consumer or this consumer, because they are connecting, they are using same group ID. In Kafka, the blind rule is one Kafka consumer of the same group can connect to one partition at the same time. So all the consumers from the same consumer cannot connect to the same partition at the same time. So that the advantage will be duplication will be prevented. Now I will show you. Okay, so it is not in our hand like when you create this topic should have the copy in this broker. No, it is not in our hand. Technically, we can't decide it. Internally, Kafka will decide, okay, this topic should go to this broker, this topic should go to this broker. So ultimately, each and every server is, each and every broker responsibility is to hold topic data. That's it. Okay, so for example, okay, let's assume this is TP1 and let's assume this is TP2. So TP1 is in broker 1. This is broker 1, broker 2, broker 3, broker 4, and broker 5. Let's assume TP3 is created with a 3 replication factor. It means that when it is created with a 3 replication factor, let's assume this for this topic, the partition will be, for example, one partition and 3 replication factor, right? It means that one partition will be having 3 copies. So let's assume one copy is in broker 1, another copy in broker 2, another copy in broker 3. It could be like this, or one copy in broker 5, one copy in broker 4, one copy in broker 2. So it could be in any broker inside the cluster, but there will be 3 copies of the partition. Okay, so if you connect to any of the broker inside this cluster, so total there are 5 brokers inside the cluster. So you can connect to any one broker. It means at the back end, you will be connecting to all the brokers. Although you have 100 brokers in the cluster, you just connect to one broker. Remaining 99 brokers will be automatically connect. So that is that load balancing will be automatically handled by Kafka. So that is the reason when producer automatically know if it is connected to one broker, it will automatically know to which broker and partitions it should connect to publish the data successfully. So in the case of broker failures, producer will automatically recover. For example, we have given all the 5 brokers list. and out of 5, this producer is giving 3 brokers list in their code while publishing the messages, right? So say broker 1, broker 2, broker 3 they have given. And initially what happens, they will give, okay, see here. So Kafka cluster with 3 brokers. For example, I have a Kafka cluster with 3 brokers, say broker 101, broker 102, broker 103. And there is a topic called topic K, so which is having 3 partitions. So partition 0, partition 1, and partition 2. So topic A partition 0 is in 101 broker, topic A partition 1 is in 102 broker, topic A partition 2 is in 103 broker. For example, there is a producer and it is trying to write the data in topic A. So in the producer side, they will just give the broker name and then the topic name. So whether the message should go to partition 0 or partition 1 or partition 2, that will be decided by Kafka. You don't have, I mean, producer can't decide my message should go to partition 0, my message should go to partition 1. No, producer can't decide it. Okay, so let's assume if it goes to partition 0, it means offsets will be created. It means message will be publishing. Now, if it is going to partition 1, so message will be publishing. So all these are the offsets, the boxes, the rectangle boxes you see, all these are the offsets. And if it is going to partition 2, then the message will go to here. So this is how. So here, Kafka will do an internal load balancing. Okay, boss, you go to this partition, you go to this partition, this message go to this partition. So which partition this message go to, that will be decided by Kafka itself internally. We do not have any control over it. Now let's take Ax equal to all. Ax equal to all means producer will wait for a leader plus replicas acknowledgement. It means whenever producer produces the message to topic A, so first of all, the data will be there in partition 0 of broker 101, and broker 101 will give a acknowledgement to producer that, hey producer, yes, I have your data now. Now producer will be happy, okay, my data is in leader. Now also producer will wait for broker 2 acknowledgement also. It means whenever data got copied from leader broker to follower broker, this broker will send acknowledgement to producer, hey producer, yes, your data is copied to me. Now producer will be more happy, okay, my data is getting copied to this person also. Now the data will be also getting copied to broker 103, because replication factor 3, it means that message should have 3 copies. So now the final copy, whenever the final broker says, hey producer, yes, your data, I have your data and this is my acknowledgement. Whenever producer reaches acknowledgement from all the brokers in the cluster, it means producer will go for the next message to produce the next message. Till then, it will never produce the next messages, because Ax equal to all and all the brokers of the Kafka cluster has given the acknowledgement to broker. Yes, now the broker is happy. I mean, now the producer is happy and it will produce for the next message. But in this case, there would be definitely no data loss, because data will be published into leader broker first and all the brokers will give the acknowledgement, yes, I have the copy. It means there is no data loss. You can confidently go for the to process next message. So that's what Ax equal to all. So we are going to see all these scenarios while in the concept of CLI. But this acknowledgement, this is completely back-end process. We don't process, we don't feel that, yes, it is sending acknowledgement, we don't feel that, but at the back end, this will happen. When this happens, then only the next message will be processed, otherwise next message won't be processed. Okay, here one more thing. So generally the default behavior of Kafka is going to be, I mean, in Kafka, the producer behavior is going to be Ax equal to 1. It means if we have not specified any acknowledgement, then Kafka automatically gives the producer, gives the confirmation from the leader broker. This is the default behavior. Now let's go with the producer with the message key. So producer can choose to send a key with the message. Alright. So the thing is, while producing the message in Kafka, producer can choose to send a message with the keys. Now, if key is equal to null, it means if a producer is producing the messages without giving any key, then the message is sent in round robin fashion to all the brokers. For example, I have a Kafka cluster with 3 brokers, broker ID 101, ID 102, ID 103, and I have created a topic with 1 partition, and this topic is having 3 replication factor. It means one copy of partition is in broker 101, another copy of the partition in broker 102, another copy is broker 103. That is what the replication factor 3. Right? So whenever a message is producing by the producer without a key, then the message will be distributed in a round robin fashion. So it will go to broker 101, the next message can go to broker 102, the next message go to broker 103. Now the fourth message will go. So if a key is sent, for example, if a producer is sending a message with a key, then all the messages of that particular key will send to the same partition. It will never go to the another partition. This is guaranteed in Kafka. For example, okay, series diagram. Let's assume I have a broker and I have a Kafka cluster with two brokers, broker 101 and broker 102. And I have something called topic with two partitions, say partition 0 and partition 1. Let's assume Kafka cluster is having two brokers and a topic is created with the two partitions, so with one replication factor only. Okay, so partition 0, one copy, and partition 1, one copy. So, and two partitions. Now, a producer is sending the data. If it is sending the data without a key, for example, message number 1, this is my first message. When this is being sent, it means that the message, let's assume the message has gone to partition 0 for the first time. Now, whenever a producer is sending the data without a key, say the second message is, say, message number 2. Now, this message number 2 will go to partition 1. Now, it is again sending message number 3 without a key, then the message will go to partition 0. Now, message number 4 here, message number 5, message number 6, message number 7, message number 8, like this in the round. So, when a message is being sent without a key, simply it will be distributed in a round robin go to any partition. This is not in our control. But if a key is sent, for example, message 1 is being published and it is having a key called K1. K1 is equal to message. So where K1 is a key and message is a value for that key. So initially, the message that being published with the K1 key, let's assume it has gone to partition 0. Okay. And another message being published with K2 is equal to message number 2, where K2 is another new key and message 2 is the value for K2. Let's assume this K2 has been published to partition 1. Now let's assume message 3 is being published with a key called K1. K1 is equal to message 3. Right? Now what happens is, previously there is already one message called message 1 that has been published with the K1. So, and this message has gone to partition 0, right? So, whatever the message being published with the same key, with the key 1, that will go to the same partition only. It will never go to, it will never distribute in a round robin fashion. No, this is not going to work when you are publishing with a key. The simple logic is, initially with that particular key, that message gone to which partition? To the same partition, all the messages respective to that particular key will go to the same partition. And let's assume if there is a message number 4, and for message number 2, I am giving something called K2, message number 4. And already a message with the same key has gone to partition 1, right? Now, when you are publishing any new message with the same key, that will go to the same partition. It will never distribute in a round robin fashion. So that is the difference when you publish a message without a key and when you are publishing messages with the key. All right. So if you see the example here, let's assume we have a transport company and let's assume we have 4 trucks. Like, so what all these 4 trucks will do is it will do transportation. Okay, so let's assume for all the 4 trucks we have given, truck ID 123, truck ID 234, truck ID 345, truck ID 456, total 4 trucks. And let's assume you are sitting in your office and you want to track the status of your trucks. So for example, if you want to see, hey, I want to know where is my truck location. So my truck ID 234 location is in which part. So whenever this truck ID, for example, today it is in Hyderabad and tomorrow, let's assume it is in Mumbai, day after tomorrow it is in Kolkata. So it is rotating, right? It's a transportation, right? So the thing is, whenever you enter a truck, whenever you are entering a message with this truck 234, let's assume that the message is going to partition 0. Next time, when you enter any message with this key, truck 234 is the key, that will go to the same partition. It will never go to another partition. For example, if you want to know the location of truck 456 and truck 456 is your message key, now the message, yes, today it is in Hyderabad, tomorrow it is in Mumbai, next day it will be in Calcutta, so something like that, then all the data that is publishing with this key, that will go to the same partition, which is partition 1 in this case. It will never go to a partition in Kafka. Now that's all with the producer. Now let's talk about something called consumer. Okay, so consumer means consumer read the data from a topic, and consumer know which broker to read from. So like when we are producing the data, so data is read in the order from each partition. For example, series diagram. So for example, I have a 3-node Kafka cluster where broker ID is 101, broker ID 102, and broker ID 103. So there is a topic with 3 partitions, and okay, so 3 partitions and 1 replication factor, which means each and every partition will be having only 1 copy. So partition 0 is in broker ID 101, partition 1 of topic A is in 102, partition 2 of topic A is in 103. And let's assume each and every partition is having some messages. Like in this case, these are the offsets, it means messages. Total 11 messages, it means 11 offsets. In partition 1, total 7 offsets, it means total 7 messages. In partition 2, total 10 offsets, it means total 10 messages. Now let's assume a consumer is reading the data from topic A of partition 0. So it will read in the order. Initially it will read offset number 0. Now it will read the message from offset number 1. Now it will read the message from offset number 2, then offset number 3, then offset number 4. Like this, it will read the message in a sequential order. It will never read the message in a zigzag order. First read the message from offset number 5, then read the message from offset number 2, then read the message from offset number 11, then offset number 0. No, it will never follow the zigzag order. It will follow order from each partition. So that's how data will be consumed. Now in consumer, there is something called consumer groups. So this consumer groups concept is very, very important. So follow me clearly here. Okay, so consumers can join a group by using the same group ID. Like for example, whenever a consumer is consuming the data, they can use a consumer group ID. So see, Kafka assigns the partitions of a topic to the consumer in a group so that each partition is consumed exactly one consumer in the group. Kafka assigns the partitions of a topic to the consumer in a group so that each partition of the topic is consumed exactly one consumer in the group, which means the diagram will give you a clarity. For example, I have a Kafka cluster. In the Kafka cluster, I have created a topic with 3 partitions. So topic A, see, topic A, topic A, topic A, it is having 3 partitions. Let's assume I have created this topic with 3 partitions, say partition 0, partition 1, and partition 2. Okay. Now, I have a consumer group called consumer group 1. So this consumer group 1 is the group name, consumer group name. And I have another consumer group, say consumer group 2. I have another consumer group, say consumer group 3. So total 3 consumer groups. Now, consumer group 1 is having 2 consumers, say consumer 1 and consumer 2. So this consumer is running from one application server, this consumer is running from another application server, but they are using same group name. Now in consumer group 2, there are 3 consumers, say consumer group 1, consumer group 2, consumer group 3. All these 3 consumers are running from a different application servers. Now in consumer group 3, there is only one consumer. It means only one consumer that is using consumer group ID 3. Perfect. Now the meaning of the point number 2 here is very simple. For example, consumer 1 from consumer group ID 1, the one you see in blue color, right? It's a consumer group 1. So let's assume the consumer 1, by using consumer group ID 1, it has connected to topic A and it is consuming the message from partition 0 of the topic. It means that the consumer 2 from the same consumer group ID, it cannot connect to the partition, to the same partition at the same time. It has to wait till it has processed all the messages. That's what the point number 2 is. So now, but this consumer 2, right? This consumer 2 can consume the messages either from partition 1 or partition 2, because from consumer group 1, partition 2, they have not consumed the message set. So it can consume from partition 1 and it can consume from partition 2 also. But consumer 1 from consumer group ID, now it cannot consume the message from partition 1 and partition 2, because already one consumer is consumed with the help of same consumer group ID. Now let's come to consumer group ID 2. For example, there are another three consumers which are in orange color, and it is using a group ID called consumer group 2. Let's assume consumer 1 from consumer group 2, it is consuming the message from partition 0. It means the consumer 2 and consumer 3 from same consumer group, they cannot consume from partition 0, correct? They can consume the message from partition 1 and consumer 3 can connect from partition 2. So now see, consumer 1 is connecting from partition 0. I mean, consumer 1 is consuming from partition 0. It means consumer 2 and consumer 3, they cannot connect to this partition from consumer group ID 2. And consumer 2 from consumer group ID 2, it is consuming the message from partition 1. It means the consumer 1 and consumer 3, they cannot connect the messages from partition 1 from the same consumer group ID. And from the same consumer group ID, consumer 3 is consuming the message from partition 2. It means consumer 2 and consumer 1 of same consumer group, they cannot consume the message from partition 2, because already one consumer is consuming the messages. Remaining two consumers of the same consumer group, they cannot consume the message from the same partition. Now let's come to consumer group 3. So this consumer group, by using this group ID, only one consumer is connected from one of the application servers. Now only one consumer, see, it can consume the message from partition 0, one consumer, and it can connect to the message from partition 1 and it can connect to the message from partition 2 also. If we have another consumer, then it cannot consume the message from the partitions with the help of consumer group ID 3. It cannot, because already one consumer is connected. As it is only one consumer which is using same consumer group ID, so it can consume from this partition. It can consume from this partition and it can consume from this partition also. If we have more consumers in a single group, it means more consumers in one single consumer group, it means that, okay, then the partitions, then some consumers of the same consumer group will be inactive. See this point. If we have more consumers in a single group than the available partitions, which means, for example, there is a consumer group. In this consumer group, let's assume there are 5 consumers. So consumer 1, consumer 2, consumer 3, consumer 4, consumer 5, right? So one consumer group and 5 consumers are using same consumer group ID. So one consumer number 1 is consuming the message from partition 2, and consumer 2 is consuming the message from partition 1, and consumer 3 is consuming the message from partition 3. It means there are 2 remaining consumers, right? They will be inactive because they won't connect to these partitions, right? They can't. Already all the 3 partitions are occupied by all the 3 consumers. So remaining extra consumers, they have to be inactive. That's it. So Kafka guarantees that message is only ever read by a single consumer in the group. So what Kafka will do is, whenever a consumer consumed the messages from a consumer group from a specific partition, the another consumer, it cannot consume the message again, because already this group, whenever a group message got consumed by a group ID, it means it will make a commit entry in Kafka. Now any another consumer freshly connect to the same partition and try to consume the message from the same partition, Kafka will have an entry. Boss, already one consumer is connected by using this group ID. Now I can't give you the messages. So that's what Kafka will do. Kafka stores the offset at which a consumer group has been reading. For example, see, the offsets committed live in Kafka in a topic called __consumer _offsets. Whenever we have started a Kafka cluster, right? The Kafka cluster automatically creates a topic called __consumer _offsets. So this is completely managed by Kafka cluster itself. We do not have any control over this particular topic. Now, in this topic, what it will do is whenever any consumer is consumed the messages from any partition by using a consumer group ID. Now, in this topic, Kafka makes the entry, Kafka makes a track. Okay, this particular consumer group has consumed the messages from this topic partition. It means whenever any new consumer is consuming the messages from the same partition by using same consumer group ID, I should not give that message to that particular consumer group because I already have the entry in this topic. So to straight away to give an answer to your question, whenever a consumer group ID, a consumer consumed the messages with the help by using a consumer group ID, in Kafka, this consumer underscore topic makes a track. Okay, this consumer group ID already committed these many offsets in my partition. So this will be tracked by this topic in Kafka. For example, whenever a consumer group has processed the data received from Kafka, it should be committing the offsets in this topic. So whenever any consumer group has processed the data from Kafka, so Kafka will make an entry. Okay, in this consumer group has consumed these many offsets from these many partitions. So that's how Kafka behaves. For example, and what is the advantage of consumer offsets? Very simple. See, for example, there is a consumer from consumer group. It is consuming the messages. And if you see 4258 is an offset, 4259 is an offset, 4260 offset, 4261 offset, till 4269. These are the offsets. Okay. Now the thing is, a consumer, it is using a consumer group ID and it is consuming the message. For example, first it has consumed the message from offset number 4258. So this topic Kafka will make a track in this topic. Okay, 4258 is already consumed by this consumer group ID. Now 4259, it will make an entry here. 4260, it will do commit here. 4261, message dot consumed. So it will make a commit here. It means Kafka. Now 4262 successfully successfully read. It means Kafka will commit that message in this, and it will make an entry like this message, this offset has been committed. Committed means successfully processed. Now 4263, let's assume the data is being read. Process is not completed. A consumer by using consumer group ID is consuming the messages, and all of a sudden, due to some network glitch or due to some any issue, the consumer died. Consumer died. Okay. Now Kafka have an entry that okay, this consumer group already committed till offset number 4262. Now let's assume the consumer after 3 minutes again it came back and it is again try to consume the messages from the topic. Now instead of it is using this consumer group. Now instead of consuming the messages from the beginning offset, from the first offset, what Kafka will do is Kafka will first go to this topic and it will verify, okay, this consumer group ID committed till which offsets it is committed till offset number 4262. But 4263, it is still uncommitted. Fine. So let's give the message from this 4263 offset. Now 4263, 4264, 4264, everything will be committed as soon as messages are consumed. So the advantage is going to be whenever a consumer all of a sudden consumer dies are disconnected, whenever it is connected back, so the message will be consumed from where it left off instead of consuming from the beginning offsets. That's the advantage of using consumer group. Kafka will make an identity. Okay, this consumer group has consumed till here. Whenever this consumer connects from connects again after a few minutes, after a few days, with the help of same consumer group, now I have to give the message from this particular offset only, because Kafka now have something called committing in consumer offsets. So that's what the advantage of consumer offsets. That's what the advantage of committing the offsets with the help of consumer group. Okay, so this is completely internal, so you no need to worry about it. So this is completely thing. Only the thing is the consumer in real time, they definitely use a consumer group ID. No consumer will connect without an identity. They definitely use a consumer group ID. So let's talk about something called Zookeeper. So Zookeeper manages brokers. So Zookeeper is altogether a different concept. So simply we can say Zookeeper manages your Kafka brokers. Zookeeper performs leader elections per partition, and Zookeeper sends the notification to Kafka in the case of changes. For example, when you create any new topic, when a broker dies, when a broker comes up, when it delete topics, so everything will be managed by Zookeeper. Simply, you can say Zookeeper manages your Kafka cluster, and without Zookeeper, there is no Kafka. Okay, the thing is, in order to create a Kafka cluster, first of all, you have to start the Zookeeper in your Kafka cluster. So Kafka cluster is always a combination of both Zookeeper and Kafka. Then only it is called as a perfect Kafka cluster. If you want to start Kafka cluster without Zookeeper, no, there is no possibility. You must have the Zookeeper because Zookeeper manages a distributed platform. Okay, so simply we can say Kafka cannot work without Zookeeper. And Zookeeper by design operates with odd number of servers. For example, I have decided I want to have a Kafka cluster in a production environment. Now, before deciding Kafka cluster, how many brokers you should have, first of all, you have to decide how many Zookeeper quorum you should have, like how many Zookeeper servers you need to have in your Kafka cluster. And by default, I mean, generally, Zookeeper should always have a odd number of servers. Like in your Kafka cluster, you should have 3 Zookeeper servers, or should have 5 Zookeeper servers, or should have 7 Zookeeper servers. That you need to decide. Like in the multi-node Kafka cluster, we are going to discuss about the importance of a Zookeeper. So not right now, but right now blindly you can remember, without Zookeeper, Kafka cannot work. As simple as that. So Zookeeper is also having something called a leader and the follower, which means, for example, in my Kafka cluster, if I have created a 3 Zookeeper program, out of 3 Zookeeper servers, 1 Zookeeper will be leader, remaining 2 Zookeepers are going to be the followers of this particular leader Zookeeper. And what is the advantage with this leader Zookeeper and follower Zookeeper? We are going to discuss in the multi-node Kafka cluster.